So one of the most, I suppose, harmful things that I see students come in with into the Learning Center is, I guess, incorrect judgment of when to allocate memory within a function versus when to not when they are programming in C or C++, but specifically C in this case. So I guess this is a demonstration that I would like to show of when to do what and how you should do it. And I guess I'd want to start off with the makefile just so I can give a few tips there to any potential students that may be watching. So it doesn't really matter what compiler you use. In my case, I'm using Clang. I always want my warnings to be errors, so this just says that the compilation will fail if there are any warnings. I use C11 because only out-of-touch people use C89 or C99. I don't see any reason for not taking full advantage of modern compilers because realistically, you're not programming for an older computer, and if you were, then you can deal with it and you can cross-compile because I don't see the point in programming in an outdated language. Anyways, I also like extra warnings. So moving on, I just build these two source files that I have up here, and then I clean them up. That's all that's really going on past that. So let's look at the first example. Um, so necessary header files, we don't need to cover those. But this is kind of the data structure we'll be working with in these examples. So in this case, we have a fixed max length string with up to 255 characters, including the null terminator at the end is 256, and we represent the length in an unsigned integer. Is this needed for something of this size? Absolutely not, but we do it anyways because that's just a really nice type right there. So we have the length stored and a little extra white space, one of my biggest pet peeves. We have an enum, and this is just for return code. So depending on our functions, if they succeed or not, we're going to return a success or failure. So I hope that makes sense so far. We'll go a little bit slower for the actual functions themselves, but all you need to know is that in this example, we have a string data structure that is up to 255 characters, and we have codes that can be returned based on if a function succeeds or if it fails. So moving on to our first function. This is the one we'll be implementing first. We are initializing a string. So this is one of my biggest points I'd like to bring up for this type of discussion, is that it is kind of a terminology you would use for, say, not allocating memory when you are creating an object or an instance of an object. Typically, this is an initialization. You're not creating it; it's an initialization. So whenever I write code, in this way, I would call it init string or any other indicator that you are not allocating memory in such a way that it would be a creation or something similar, right? Um, so in this case, we have strings. We have two early error checks because I like to check errors as soon as they can be introduced, not when they start to cause problems. Putting your error checks early so that you can see as soon as where they become a problem rather than when they start problems is the best practice you can do for yourself when you have to read your code later on and for other people who have to read your code. So that's what I'm kind of doing here. We check if either the pointers are null. If they are, that's invalid because we need to be able to use our pointers. And we check if the length is oversized for our string. So those are our two times we return failure, and we return a success if we get to the end of the function. So let's go ahead and implement this thing. So this is assuming that we don't need to allocate memory, so this already exists, and the length of this is going to be equal to the length that's passed in, and then the data we will copy over from what's passed in. With a memcopy. And then after we do that, we'll just go ahead and be a little safe and put a null terminator on the end of our string. Can't really type today, can I? There we go. New keyboard. Anyways, there's our little initialization of a string function. I believe that is all we need. Let's go ahead and run the example. So let's talk about the example first. I suppose that might be a good idea. All that's happening here is we have two separate, usages or ways to use a function like this. The first one, we just create a string variable on the stack, we pass a pointer to it, or we pass the address of it, copy the text to it, and then specify the length. And then for both of these examples, I'm just printing out the string and how many characters long it is. In this second example, we actually allocate the memory for a second string, and then we initialize it just as before, and treat the pointer. There's no ampersand here because it's already a pointer, and then we print the exact same thing. I believe that is everything, but of course we might not exactly build perfectly on this first time around. Looks like we might have. There you go. So our example works perfectly. So let's go ahead and try working on this second example. So it's pretty much the same, except notice this change right here in our data structure, and that is that the data is actually a pointer this time. It's a char pointer instead of a char array that we had before, right? But other than that, it's the same length. We have our return codes, but then our function changes a little bit. So now, instead of returning a return code, we have a pointer to a string, and this is being returned by the create string function. So the reason for this is because we are going to be returning a pointer to allocated memory, thus creating the string, right? This is not initialization anymore. This is the actual creation, and we will also initialize it within. So that is an important distinction to make there. After that, we will go ahead and do our early error checking as we said before, and then at the end we return the result. Since we don't have the ability to return the code, we just return null on failure. So it's still able for the user to check whether the function failed or not, but this is a little less robust. So now let's go ahead and implement this function. So we're going to create our string variable, if I can type, and we'll say that string is allocated memory. So this is the pretty standard procedure for creating such a thing. We'll set the members accordingly, and then just as before, yeah. One thing to note that I almost messed up here is that this is not that we don't have any data yet. This data is just a pointer, if you remember. We haven't allocated any memory. So now, this is where the big advantage of this comes in, is in the case of something like this, if you want to create something on the stack, like we did right here, you would have to make sure that nothing within it would need to be allocated. And while that isn't entirely true, you very well could pass a function or pass an address to a string here and then allocate memory to this data. But then what you're talking about is you are allocating for one thing but not the other. And that is a kind of a point I want to drive home, is that if your function is going to do one thing and then a completely different thing when it could be doing the same thing for both, I guess, instances, then you should go with the latter there. You should not be allocating your data but not your actual object. You should be doing one or the other, and that's what I'm kind of trying to show here. And I almost messed up because I didn't allocate the string within the string. So one thing I also want to point out is that in the C standard, a char is guaranteed to be 1 byte in size. So we don't need to specify the size of operator, and it is an operator, by the way. It's not a function. Fun fact. We can just malloc the length, and don't forget we want some room for that null terminator. And now we can just set the null terminator. There we go. So we've created the string, we set the length, we set the data, we copy it over, we store the string in there, and we've created another function. So one more thing I want to point out is whenever you have a function that's creating something, and this is especially common whenever you have a function that is not only allocating the type itself, or the instance of the struct itself, but it's also allocating for these members of the struct. So typically when you have something like that, you want a destroy function. So again, we have the early error checking. The destroy function is also going to be freeing all allocated memory, so that includes the string's data and the string itself. And then finally, we are back down here with the same basic example we had before. This is not going to work. It did. There we go. I am surprised as you are that that worked on the first shot. Definitely going to edit this video a little bit. It's not usually how I like to do things, but I definitely messed up on some parts here and there. Well, let's make the whole thing and then Valgrind both of these just because I like to make sure that I did not have any memory leaks in any of my code. And there you go. Always be thorough, always be safe. Remember, C does not need to be hard. People tell you it's hard because they want to sound smart, but it's not. If you want to learn how to program in C, if you want to be successful, all you have to learn to do is think. And eventually you do enough thinking and the thinking becomes second nature. Anyways, thank you for watching. I hope this helped you in some sort of way, and I hope to see you again in the future.